This is a high school geometry lesson in how the tangent came to be and how it works. Okay, so we're going to discover a tangent. We'll start with this sheet. What we're going to do is draw a diagonal, and we're going to make triangles out of it. So what that will need to be then is, I'm going to ask you to make, if I'm at my pen here, I'm going to ask you to make a diagonal on it from somewhere in this region from one place for your straight edge, and somewhere, okay, on the bottom edge here and on the side edge here. You're going to choose any place that's convenient to you that has right at the crosshairs. Okay? And up here, same deal. Try not to make this isosceles, not because it doesn't work for isosceles, but because isosceles is boring in this application. It still works, but it's just uninteresting, less interesting. Okay, so you're going to do this starting right on the crosshairs and draw a diagonal. And go ahead and finish out an angle here by doing the bottom one, or it doesn't have to be the bottom one, but the bottom one works, of your graph paper. Okay. So we'll have an angle here. Then we're going to make a triangle. Make it kind of a small one. Try to find some place where it's right at the crosshairs. We'll do that one right there. Work. So that one will be vertical. Okay. So I made a right triangle. Well, let's see what we can say about this right triangle. Well, there's an angle down here, which I'm going to color in. And when I talk about this right triangle, obviously that's the hypotenuse. So I'm just going to call this the hypotenuse. Go ahead and label yours. Now for trigonometry, we talk about the sides, the legs, and the hypotenuse of the triangle relative to a particular angle. So first I'm going to talk about it relative to this angle that I've colored pink. Okay, relative to this angle that I've colored pink, across from it, or opposite from it, is this side. So I call it the opposite side. And there are two sides that are adjacent to it, but the hypotenuse already has a name. So I'm going to call the other one adjacent. It's adjacent to the angle that I'm talking about. I'm talking about the pink angle. This side is opposite, this side is adjacent to it. Okay, I'm going to count how long these sides are. This one is 11, and this is 7. Okay. So the opposite side is to the pink angle is 7, and the adjacent side is 11. Okay, up at the top of your sheet, there's a little chart that also says opposite and adjacent. We're going to fill that in. So I'm calling it the bottom angle just because it's kind of towards the bottom and kind of towards the top. That's not a technical term. It's just what I'm using to try to figure this out. So my bottom angle is pink. And when I counted it, the adjacent leg was 11 and the opposite leg was 7. So go ahead and write yours in. Make a fraction out of it. Opposite over adjacent. 7 over 11. Then we're going to make a decimal out of that with our handy dandy calculator. and we'll get that it's 0.63636363. You can put as many as 4 decimals if you can get it in there, or if you have it, that's fine. Definitely put 2. 4 is fine too. 4 will be good. Okay. All right. So that's opposite of my pink angle, the ratio of the opposite to the adjacent. Well, I need to talk about this other angle. I'll make it blue. Okay, so relative to this angle, the blue one, the upper one here, this is now opposite. But it's still 11. And the side here, the vertical, is now adjacent to it. Okay? So I'm going to write that in up here. Notice it'll be my same numbers, but they'll be in a different place. So here's my top angle. The adjacent leg is 7. The opposite leg is 11. I'll make a fraction. Opposite over adjacent. And that's going to be 7, so that's going to be a mess. It's 1.5714. Okay? So those are the ratios within this triangle. So you go ahead and do those with yours. Pause it if you need to. Okay, then you're going to come back and put in 3 more vertical lines. Don't make them evenly spaced if you can help it. Just find some place where it looks like it's on the crosshairs. Or you can count by halves if you want to. Okay, and I'll try this one. Yeah, I'll do one that's closer. Like maybe this one right here. These are all crossed right because all of these are parallel and perpendicular. But I'm going to go all the way here to the end. Might as well. Your error tends to be less when it's longer. So just choose any 3 more places that you've got. If it can be a different distance, that's nice, but it doesn't really have to be. So now go ahead and do the same thing for these 3 triangles. And notice that what we've just done is made 3 similar triangles. They all have the same pink angle in the corner. The sides, these legs are parallel. This is a transversal, therefore all the blue angles are also congruent. So we've got an extra angle, 3 angles that are the same, so these are similar. And go ahead and do the same thing for each one of them and put in your results. When you're done, average the decimals. Don't try to average the fractions. Average the 2 decimals from the top angle and from the bottom angle. Okay, and when you get that done, and also notice while you're doing it, this little diagram here, this is a different one, but it's the same. It's going to be the opposites and the adjacents. As you go along, this will stay the same color, but these will substitute for that. When you get them all done, it will look something like this. Okay. And what I'd like you to do now is measure this angle. The angle that's down here. So measure the angle. My angle I measured to be 34 degrees. 34 degrees. Now we're going to deal with what we're doing. We'll talk about what we're dealing with here with the tangent. The tangent is just a relationship of similar triangles. We have 4 triangles here that are similar. We know that their sides are proportionate, and being proportionate, it'll always be in the same ratio. Okay? So, and whenever you have the same angle in the orange one, the bottom one, you'll have the same angle in the blue ones, the top ones that are here. Which means that the opposite and adjacent will always form the same ratio if the angle is the same. That's what tangent is. So what we're dealing with here, we've got the opposite to adjacent ratio. Okay? And in this particular case, which one did I have? In this particular case, that's going to be, well, for the bottom one, 7 to 9. Okay. And we could turn that into a decimal. And we turn it into a decimal, I think it's going to be 777. Yeah. And if you round it, you'd put the last one as 8. 4 decimal places is a good number. That's what's commonly used. Okay. I've got it there with 2. So, take and measure yours. Mine was about 34 degrees. Okay. Then I'm going to tell you how this will work to do that. So the measure of the angle is about 34 degrees. Get you a protractor and measure your angle. Remember to put the hole in the protractor right exactly there. Okay. So what else can we do with this? Okay, people did this a very long time ago. They'd make like huge triangles and measure both of the sides and find the ratio, and they found out that it was always close, like hopefully that you just found out here. Okay? And they started noticing that it was always the same if it was with the same angle, and figured out that that could be handy. You know why? Because it's really handy. This is useful for all kinds of things. They did it so much that they made charts. You have a chart like this in your supplies. There's also one, this is just borrowed from your textbook, but there are whole books that just give these ratios. Back in the old days when we didn't have calculators. So if we look at this and we say this angle was 34 degrees, 34 degrees is right there. And I'm going to tell you in a bit, but just a hint. The name of this is the tangent. You're doing a tangent discovery. And you look here and you see, yes, indeed, you look under the tangent column and it's 0.6745. Okay? So the ideal is 0.6745. So mine was off by a fair amount. That's why you do it a whole lot of times. This is a pretty little triangle to be doing. By the time you get out to the big triangle, it's generally going to be better. That's why we do them and take the average, and that is actually how folks originally arrived at all these things, by doing really huge ones and counting it with little bitty units so that they got it more and more accurate. Okay, so this was the one that I did with my little triangle, and this is the one from the chart. Okay, let's talk about another way to do it. Another way to do it is from the calculator. Now let me warn you, on the calculator, you're going to make a mistake one time or another. And here's the mistake, and everything you do is going to be wrong if you make this mistake. And it's silly, and it's easy, but you're going to forget it anyway. The calculator has defaults for all kinds of things. This is one of the things it has a default for. There's 2 ways that most people do trigonometric functions. One with radians and one with degrees. Now, we're not talking about radians at the moment. We're talking about degrees. But this calculator sets its default at radians. So you need to go to Mode, see Mode, and when you pull it up, unless it's been reset, this is what you'll see. Right there is radians, but what you want is degrees. So arrow down to radians, so it's going to blinky blink, and over to degrees. Now that's not good enough. You got to actually hit enter and make sure that degrees is highlighted. Now once you do that, you're gonna be fine, and it will work. If you don't, it won't work. And I'll tell you a little clue here. I forgot to do this when I was preparing the supplies for this unit. I was working out one of the versatiles to see if it would work and to get the answers, and I tried and I got them all wrong. I said, what am I doing wrong? So I put it aside. I came back and I got the same wrong answers again. I said, what's wrong with me? So I went and did something else. So then I came back and I said, oh no, I didn't change the calculator from the default from radians to degrees. And I've been doing it for years and I forgot. So you got to make sure whenever you use a calculator that you do that. There are some geometry teachers who insist that their kids use the chart. No calculator. Why? Because it's so easy to make that mistake. So please make sure that you don't do that, because you'll get everything wrong, and chances are you won't know why you did it wrong. Okay, so when you're all done, or at least at this point, you'll come, and here is my, ooh, I measured that one at different places, and that one's better. Yeah, I did this at a different time. Okay, so 34-degree angle, you put it into the calculator. So I want you to write your measurement of your angle here, and write here your average decimals. Do the same thing for the other angle, and see what your two are. Then take the calculator if you have one, or the chart if you don't. It works just fine. Well, here, I'll do the chart first. Okay? Here's the chart. It's the same one I just did. 34 tangent is 0.6745. So I write in this blank space here that the tangent, T-A-N, that's the abbreviation, of 34 is 0.6745. Okay, to get it from a calculator, I've made sure, yes, really sure, that it says degrees. So now I can get out of there. How do I do it? The tangent button is right here. It says tan. So push tangent. And then the number of the degrees, 34, you don't put a degree sign, and hit enter. And it'll tell you, yes, indeed, 6745 and a whole bunch of numbers, because these are irrational numbers. Okay? So you'll put in here the tangent of your tangent of yours, and write in the one from the calculator or the chart, and then do the same thing here. Okay, to be able to put this into your cipher, I'd like for you to fold it. You don't need to write on it, but write the word tangent up here so that you'll know what it is. I like you to be able to see things at a glance when they're in your cipher, so you don't have to waste time. So write tangent up there. You can put tangent discovery here or something here if you want. That would work too. Fold it so that you can still see the tangent. Then you're going to take your cipher to the notes section. The next place in your notes, you're going to paste it in. So I'll put mine right here. So put glue stick all on the back, turn it over, paste it in right like that, and that way you can flap it over. I don't let you fold stuff much, but I do want you to be able to see what it is right on here, right there, so you know what it is. Paste it in good so you'll have your tangent. And believe it or not, this is really how people did it a very, very long time ago. Centuries. I don't know exactly how many centuries, but a long time ago. That's how it was done, and you just duplicated how that came to be. So, here endeth the tangent discovery.